All right, so we're going to go over another example of classifying a quadrilateral. Again, first step is to draw the quadrilateral. Here we already have it drawn for us and the vertices given to us. So we'll go on to step two. Step two, remember, is to use the distance formula to find the lengths of all the sides. So following here, let's find the length of side AB. So to do that, we use the distance formula. Square root differences of the x's squared plus differences of the y's squared. Right. So clean this up. We end up with -6 squared plus -4 squared, which is then 36 plus 16, which gets us the square root of 52. And again, I like to mark as I go along. Next, we need to figure out what's the distance from D to C. So D to C, that's going to be 1 minus -5 squared plus -3 minus -7 squared. And again, I'm going to use the calculator here to quickly finish up my calculations. So we end up with DC as, again, square root of 52. So once I've got those two, again, I mark it. And then now we've got to figure out the other two sets. So we've got to figure out AD. So AD is going to have the points -7 minus -5 squared plus -4 minus -7 squared. Again, I'm going to use the calculator here, and I'm going to end up with the square root of 13. So mark it on my picture. And then last side, BC, that's going to be -1 minus -5 squared plus 0 minus -7 squared. Once we simplify this, we end up with the square root of 13. So after we finish the distance formula, we can still check our matrix to see what possibilities do we have here. Now, we do know that opposite sides are equal, so it could be a parallelogram. We do have opposite sides equal. Could be a rectangle. Let's see here. Slopes, and here it cannot be a kite, as our sets are not adjacent to each other. It cannot be a rhombus, because not all our sides are equal to each other. And it cannot be a square, then, as a square is both a rhombus and a rectangle. So now we have to take a look at slopes, right, to figure out whether it's a parallelogram, trapezoid, or rectangle. So now we need to take a look at slopes. Let me just erase this. All right, so slope of AB. Using our slope formula, we're going to have -4 minus 0 over -7 minus -1. That gets us -4 over -6, which then simplifies to be 2/3. So again, copy it here. You may need a little bit more space on your sheet of paper. Then we need to take a look at the opposite slope. So we'll take a look at slope DC. That's going to get us -3 minus -7 over 1 minus -5. Again, I'll use the calculator here, and it turns out that the slope is 2/3. All right, so on to our other two sides. Slope of BC, that's going to be 0 minus -3 over -1 minus 1, which gets us 3 over -2. And then the slope of AD equals -4, subtract -7, over -7, subtract -5. We end up with -3/2. So I'll mark those on my picture here. So when we take a look here, our opposite slopes are equal. And we have two sets. So trapezoid is out since we have two sets. We have figured out that the opposite slopes are equal. But we really need to figure out is, are the adjacent slopes opposite reciprocals? Remember that they have to multiply to be -1. So let's take a look. If I take a look now, I'm going to erase my work here so that I've got a nice clean slate. If I take a look at my pairs here, I've got 2/3 times -3/2, which gets me -6 over 6, which is -1. I take a look at the next pairing, which is 2/3 times -3/2, which gets us -6 over 6, again, which is -1. And if you continue the pattern between these two and these two here, you'll find out that those will be -1 as well. So opposite slopes are reciprocal. I'm sorry, the adjacent slopes are opposite reciprocals. So our final answer is that ABCD is a rectangle.